Archimedes stepping into his bath, Newton and the falling apple, Kekulé dreaming of a snake eating its tail, and waking up knowing the structure of benzene. The sudden, out-of-nowhere insight, the aha moment, has fascinated psychologists for over a century. What is happening in the brain when the solution arrives complete and unbidden? And can we train ourselves to have more of them? An algorithm is a systematic, exhaustive procedure that guarantees finding a solution if one exists by methodically working through all possibilities. Algorithms are the method computers use to search databases, solve equations, and find optimal paths. In human problem solving, algorithms are used when the problem space is limited and a methodical approach is feasible, checking every possible combination of a 4-digit PIN or working through a proof step by step. The guarantee of correctness comes at a cost. Algorithms can be extremely time-consuming when the problem space is large. Mental set is the tendency to approach new problems using strategies that worked in previous, similar problems, even when those strategies are suboptimal or inapplicable. Lookins' water jar experiments demonstrated this. Participants who had solved a series of problems using a complex multi-step formula often failed to use the simple, direct solution when it was introduced later because they were locked into the previously successful strategy. Mental set is a form of functional fixedness applied to problem-solving methods rather than objects. The habitual approach becomes an obstacle. Functional fixedness is the cognitive bias of perceiving objects only in terms of their usual function, which prevents seeing alternative uses that could solve the problem. Dunker's candle problem demonstrates this. Participants given a candle, a box of thumbtacks, and matches often fail to realize that the box itself can be tacked to the wall as a platform for the candle, because they see the box as a container for thumbtacks, not as a separate object. Priming people to think of the box as a box rather than as a thumbtack holder dramatically improves performance. Joy Paul Guilford distinguished two types of thinking central to creativity. Divergent thinking generates many different possible responses to an open-ended problem, brainstorming alternative uses for a brick, imagining multiple plot endings, generating unusual associations. Convergent thinking evaluates the possibilities and selects the best solution to a well-defined problem. Creativity requires both, divergent thinking to generate the pool of ideas, and convergent thinking to evaluate, refine, and implement them. Tests of creativity often measure divergent thinking through alternative use tasks and unusual association tasks. Teresa Amable's componential model identifies 4 necessary components for creative output. Domain-relevant expertise is the foundational knowledge base in the relevant field. You cannot be creatively original in a domain you do not understand deeply. Creative thinking skills include the capacity for analogy, associative thinking, and tolerance for ambiguity. Intrinsic motivation, doing something for its own interest rather than external reward, is crucial. Extrinsic rewards can undermine creativity by shifting focus from the work itself to the reward. Supportive social and organizational environments provide the freedom and psychological safety that creativity requires. Insight is the sudden, seemingly discontinuous arrival of a solution to a problem that has resisted analytical approaches. It is characterized by the aha experience, a strong feeling of certainty that accompanies the solution's appearance, along with an abrupt shift in understanding. Insight is phenomenologically distinct from incremental problem solving. It feels like the solution arrives complete rather than assembled step by step. Researchers have documented a neural signature of insight, a burst of gamma wave activity over the right anterior temporal lobe approximately 300 milliseconds before the aha moment is consciously experienced. The incubation effect refers to the finding that taking a break from a problem after an initial period of intense effort often leads to subsequent insight. The solution appears to emerge while the person is not consciously working on the problem. Incubation is thought to work through several mechanisms. Forgetting failed approaches, which frees the mind from fixation. Spreading activation in semantic memory, which may activate remotely related concepts. And continuing unconscious associative processing that is not available to introspection. Sleeping on a problem leverages both incubation and the memory consolidation that occurs during sleep. The remote associates test, created by Sarnoff-Mednick, measures the ability to find a single word that links three otherwise unrelated words. For example, the linking word for pine, crab, and sauce is apple. This remote association task captures a cognitive component of insight, the ability to make connections between distantly related concepts. Performance on remote association tasks correlates with real-world creative achievement and with divergent thinking scores. It also correlates with positive mood. Good moods expand the semantic associations available in working memory, facilitating the remote connections that insight requires. Problem-solving and creativity are at the heart of what makes humans adaptive. Understanding mental set, functional fixedness, and the neuroscience of insight provides concrete principles for improving problem-solving performance. Broaden perspectives, change your approach when stuck, take breaks, and create conditions that support intrinsic motivation and psychological safety for unusual ideas.